Hi friends, I hope you have a nice Thursday. It brings you nothing but joy. We have been introduced to the concept of rotational rate in the previous video. How about this time we discuss a simple problem about it? We are asked to calculate the magnitude of the rotational rate at a point located in a velocity field. I am sure you still have an idea of the formula for calculating the rotational rate. But there is no wrong in looking at it once again. This rotational rate can be calculated using the omega equation. The factors on the right side are quite difficult to memorize. If we have ever studied linear algebra or vector analysis, we will be familiar with matrix determinants. This form of writing can be written in the form of a determinant of a 3x3 matrix. If it is like this, it will be easier for us to remember it. Back to our problem. There is a velocity field written there, and the coordinates of the test point. Let's just write the omega equation. The velocity vector contains two vector components. That is the velocity field in the x-axis and the y-axis. So the component in the z-axis is 0. Now, we can apply the concept of matrix determinants. 0 partial u partial z j hat plus partial v partial x k hat minus partial u partial y k hat minus partial v partial z I hat minus 0. This is the equation of our omega vector. Based on the equation of the velocity field, the velocity component in the x-axis is minus 0.5 xy. The velocity component in the y-axis is 2y squared. Partial derivatives are a familiar calculus process. This partial derivative is 0, because the u component is independent of the variable z. This partial derivative is 0, because the v component is independent of the variable x. This partial derivative is minus 0.5x. This partial derivative is 0, because the v component is also independent of the variable z. The omega vector is equal to 0.25x k hat. This equation can be used to calculate the rotational velocity of any point. We are asked to calculate the rotational velocity at point 21. At this point the value of x is 2. Omega is 0.5 k hat. Evaluate the answer to this question. The sign of this value is positive. This means that at point 21, the direction of rotation is towards the positive z-axis. Happy learning, everyone.
I like to be educated, but I'm so frustrated.